Hello students, welcome back to Marvel Classes and Marvel Math by Akilan Institute. In this video, I am going to explain the concept and solution of top 20 important model questions from real numbers chapters, part 1. In this chapter, only two exercises are there. One is fundamental theorem of arithmetic and second one is irrational numbers, and this is most important exercise. First question, check whether 6 power n can end with digit 0 for any natural number. Any positive integer ending with digit 0 is always divisible by 5, always divisible by 5, and so it is a prime factorization of numbers along with 5. But here 6 power n equal to 2 into 3 power n, 2 power n into 3 power n, but in this factorization there is no 5 and hence it cannot end with digit 0. Write proper conclusion. Prime factorization of 6 power n does not contain 5 as a factor, hence 6 power n can never end with digit 0 for any natural number n. Similar question you can practice, 4 power n, 12 power n, this type of question you can practice. You can expect in 2 marks. Explain why it is a composite number. Always write the given expression. This is one term, another term. These two terms, this is a common factor. If you take 13 as a common factor, here the remaining factors in the first term is 7 into 11. 7 into 11. From second factor it is 1. Correct? So 7 into 11, 77 plus 1. I will explain here. 7 into 11 plus 1 into 13, which is equal to 77 plus 1 into 13, which is equal to 78 into 13. 78 into 13. So therefore this number is divisible by 78 and 13 and hence it is a composite number. So what is the reason for composite number? If a number which is divisible by more than two numbers, that is a number itself and 1, but here other than number itself and 1, two more numbers 78 and 13 also divisible, therefore it is a composite number. Question number 3. This is also 2 mark question, 2 or 3 marks. One of the very important question in this exercise, word problems related with HCF and word problem related with LCM. The given question is 3 different containers contain 496 liters, 403 liters and 713 liters of mixture of milk and water respectively. Which biggest container can measure all the different quantities exactly? 3 big containers with different liters of milk and water. Question is, which biggest container can measure all different quantities? That is, what is the size of the container which is equally filled with this? So for that this problem is related with HCF. So first 496 equal to 2 power 4 into 31. Use this prime factorization, correct? 496 by 2, 248, again by 2, 124, again by 2, 62, again by 2, 31. So 2 power 4 into 31. Similarly 403, 13 into 31, and whenever if it is very big number, okay, whenever it is very big number, and it is not, if you are struggling to find the factors, always take this, any one of these. 2 is not possible, therefore take 31. So take 31 and hence it is 13 times. Similarly 713, so take, but 31 is there in both the cases, so 31, so 2 times 62 and 93 3 times, so 23 into 31. And what is the common factor? The common factor is 31. So HCF is 31. So question is, which is the biggest container can measure all different quantities exactly? The container quantity is nothing but 31 liters of milk and water. So you need a small container which contains 31, which has capacity of what? 31 liters of milk and water. So this is a problem related with HCF. Next. Find the largest 4-digit number exactly divisible by this, First take these 4 numbers. Instead of finding separate prime factorization, you can find prime factorization at a time whenever the problem is related with only LCM. So first by first prime number to 6 times 15 as it is, 9 times 27 as it is. Next 3 times, 3 using prime number 3, 2 times, and this is 5 times, 3 times and 9 times, again 3. Okay, now if you multiply all the numbers, LCM of these two numbers equal to 2 into 2, 2 square, and 3 and one more 3 cube, and last 5 into 5, which is equal to 540. But question is 4-digit number, but 540 is not a 4-digit number. Then find the largest. How to find the largest 4-digit number which is divisible by all the 4 numbers? So multiply by any number. First multiply by 20. You always start with the number which is multiple of 10. So if you multiply by 20, it is 1800. But question is, largest 4-digit number means what? 999. Okay. So less than or equal to this. Correct. But this is more than. And if you reduce this number, if you multiply by 19, it is 10,260. But if you multiply by 18, this is 9720. So 18 times 540 is 9720, which is the largest 4-digit number divisible by 12, 15, 18 and 27. So one of the tough 2-3 mark question. Okay. First find LCM. That LCM is less than this number. This number is less than 999. Okay. And hence multiply by a number which is multiple of 10. So if you multiply by 20 more than this number 9999, again if you multiply by 90, then also it is greater. But if you multiply by 18, it is less than 999, 9999, and hence this is a required 4-digit number which is divisible by 12, 15, 18 and 27. Next, one of the tough question, hearts category. LCM of two numbers is 45 times HCF. LCM equal to 45 times HCF. L equal to LCM, H equal to HCF. So given condition is, what is given? Given is LCM equal to 45 times HCF. So L equal to 45H. But what is the second condition? One number is 125 and HCF, and sum of HCF and LCM is 110. Sum of 1150. So LCM plus HCF equal to 1150. This is also given. So this is a linear equation. LCM plus HCF equal to 1150. But one condition is given. What is that condition now? LCM equal to 45 times HCF. So replace L by 45H. So 45H plus H, 46H. 46H by 1150 equal to 25. Therefore HCF equal to 25. Now question is, find the other number. So HCF is calculated. HCF equal to 25. And what is LCM? LCM equal to 45 into 25. So 1000, 40 into 25, 1125. LCM equal to 1125. And one number is 125. One number is A equal to 125. Our aim is to find B. So what is B equal to? LCM into HCF by A. So LCM is 45 into 25 into HCF. What is HCF? 25 by 125. Correct? Therefore 25, 125 5 times, and this is 5 times. So 45 into 5, 225. So what is 225? It's the other number, second number. One number is there, sum of HCF and LCM is there, and one more condition is there. What is the one more condition? LCM equal to 45 times HCF. So using this condition, substitute this condition here, find the value of what? Find the value of what? HCF. After finding HCF, find B. So here we need two data. One data is HCF, other data is B. For that we need two conditions. One condition is HCF equal to, this is condition number 1, and this is condition number 2. This is condition number 2. Using these two conditions, find HCF, also find B equal to 225. So this is one of the very tough question from HCF and LCM. Next question. Find the largest number which divides 245 and 1037, leaving the remainder 5 in each case. Largest number which divides these two, leaving the remainder. So which means you have to subtract 5 from these two numbers. Therefore, the numbers are 245 minus 5, 240, and 1037 minus 5, 1032. These two are the numbers. So A equal to 240, B equal to 1032. Using prime factorization, factorize this, and the factors of 240 is 2 power 4 into 3 into 5, and 1032 2 cube into 3 into 4, 43. The question is largest number. Largest number means which is nothing but what? HCF. Largest number leaving the remainder, and hence the required number is HCF of these two numbers A and B. So HCF common factor 2 power 4 2 cube is 2 cube, and 3 is the common factor, which is equal to 24. So 24 is the required number which divides these two numbers 240 and 1032. So don't forget this subtraction. Subtract 5 from these two numbers. Okay. Next question. HCF of two numbers. So these two are A and B. A and B and B. And this is HCF. Question is, what is LCM? We have formula A into B equal to HCF into LCM. Our aim is to find LCM. So what is LCM? Equal to product of the numbers by H. Product of two given numbers by HCF. So these two numbers, the numbers are 252 and 594 by HCF. HCF is 18. If you cancel these two, 1 times 72, 4 times. So 14 into this equal to 8,316. So that is the LCM of these two numbers. You can expect in 2 mark questions. So A and B are given and HCF is given, find LCM. So substitute in this formula and then find the value of LCM. So using this formula, you have 4 different types of questions. 2 numbers are given, LCM is given, this is one type. Also find HCF, find 3 types, type 1, type 2, type 3, find A or B, that is another number. Okay, 3 different types of question using this formula. Product of the numbers equal to product of HCF and LCM. So next question, find HCF and LCM of these two using factorization method. 126 by prime factorization 2 into 3 square into 7, and 156 2 square into 3 into 13. So common factor. So common factor 2 and 2 square. 2 is the common factor. 3 square and 3 is the common factor. Therefore, HCF equal to 6. Also find LCM. LCM is nothing but what is HCF? Product of the common factor with the least power. And what is LCM? Product of the factors with maximum power. Product of the factors with maximum power. So HCF is 2 into 2 and 2 square. 2 square is there. 3 square and 3 square, 7 and 13. So 7 into 13. The answer is 3276. It's a basic sum. A and B is given using prime factorization. Find HCF and LCM. So next important question. Find the largest number leaving the remainder which divides 129 and 545. Reminders are 3 and 5. 7th question, I think we have only one remainder for both the numbers, but here 2 numbers with 2 different reminders. So the numbers are 129 minus 3 equal to 126. 545 minus 45 equal to 540. Using prime factorization, 126 equal to 2 into 3 square into 7, and 540 equal to 2 square into 3 cube into 5. So the required number, largest number means largest number which divides means always it is HCF. So HCF of these 2 numbers, that is this is not A and B. A and B are 126 and this. Okay. So using prime factorization, HCF of these 2 numbers equal to product of the common factor with the lowest power, and hence 2 into 3 square equal to 2 into 9 equal to 18. Therefore, the required number is 18. So 2 different sum. Here different reminders, previous question same reminder. Next model question, problem based on HCF. A switch teller has 420 Kaju Barfis and 150 Badam Barfi. 420 and 150. He wants to stack them in such a way that each stack has the same number and they take up the least area of the tray. How many of these can be placed in each stack and how many stacks are formed? One of the very important and tough question. Usually we have a word problem only with respect to HCF and LCM, but here additional question. After finding HCF, you have to calculate additional concept. You first find a prime factorization of 420 and 150. So 420 after prime factorization, 2 square into 3 into 5 into 7 and 150 2 into 3 into 5 square. So as for the HCF concept, HCF equal to product of the common factor with minimum power. So 2 and 3 and 5, so which is equal to 30. So what is that 30? 30 is nothing but this data. He wants to stack them in such a way that each stack has same number and they take up the least area of the tray. How many of these can be placed in each stack? How many of them? 30 barfis, 30 kaju as well as badam barfi, either this or that, which be placed in each stack. So each stack contains only 30. Now next question, how many stacks are formed? How to calculate number of stacks? Very simple. Find the total number of stacks required for kaju barfi and badam barfi. So how to calculate this? Minimum number of barfis in each stack equal to 30 and number of stacks equal to 420 by 30. This is for kaju barfi. 420 by 30 which is equal to 14 stacks are required for kaju barfi and 150 by 30 equal to 5 stacks are required for badam barfi. So totally the sweet seller needs 19 stacks required. 19 stacks required. Suppose if I develop this question, what is the cost of each stack of kaju barfi and what is the cost of each stack of badam barfi? But I will give another new video with respect to that case based question. Okay. So this is one of the tough question which is related with HCF along with sum by HCF. Okay. Don't forget this additional step, this is very important. This is one of the board question. And next model question, in a school there are two sections, namely A and B of class 10. There are 30 students in section A, 30 students in section A and 28 students in section B. Find the minimum number of books required for their class library so that they can be distributed equally among the students of section A or section B. First find prime factorization of 30 and 28. Clearly the required number of books are to be distributed equally among the students of section A or section B. The number of books must be multiple of 30 and that of 28. Multiple of 30 and 28 is nothing but what? LCM. Okay. Consequently the required number equal to what? LCM. So this line is very important. So first find prime factorization of 30, that is equal to 2 into 3 into 5 and 28 is 2 square into 7. So LCM of this, else what is LCM? Product of the prime factor with highest power. So 2 square into 3 into 5 into 7. So totally 420 books. So 420 books are required to distribute equally among section A and section B. So one of the very important word problem which is related with LCM. So this is the last sum in first exercise of fundamental theorem of arithmetic and first sum in irrational numbers. Show that 5 plus 2 root 3 is an irrational number. So this method is called method of contradiction. Assume that it is rational and prove that our assumption is wrong. The proof is very important and standard. You can't change the proof pattern. Assume the given number equal to A by B where B not equal to 0 and A and B are co-prime numbers where A and B are integers having no common factor or co-prime. So it's a basic working rule, write in terms of what? For example, 5 minus AB equal to 2 root 3. So replace this irrational on the right side and simplify this. 5b minus a equal to b, which is equal to 2 root 3, and 5b minus a by 2b equal to root 3. This is irrational. Okay, this is irrational. See here 5b minus 2b. So split into two terms. 5b by 2b is 5 by 2 minus a by 2b. Minus a by 2b equal to root 3. Since a and b are integers and this is a rational number. So LHS is rational but RHS is irrational, and hence, which is not possible, and hence our assumption is wrong. Therefore, this number is what? Irrational. This contradicts about this assumption 5 minus 2 root 3 is irrational, and hence it is irrational. This proof is very, very important, and follow the standard structure of proof of each sum. And next model question, this is one of the harsh question. This has two irrational numbers. Few students will prove, they will prove root 2 is an irrational and root 3 is irrational, and irrational minus irrational is irrational. But this is a very simple proof. Assume the same method of contradiction concept. Let us assume to the contrary, this is a rational number. Therefore, root 2 minus root 3 equal to x, and squaring on both sides. If you square on both sides, root 2 square is 2 and root 3 square is 3, and 2ab equal to 2 root 6. So this is 2 plus 3 5 and minus x square. Group all rational on left side and irrational on the right side. 5 minus x square by 2 equal to root 6. So this is rational and this is rational. X is also rational. On the whole, it is rational. On the whole, it is rational, but RHS is irrational. Left side is rational, right side is irrational, which is not possible, and hence what? And hence this is an irrational number. So one important advice is these three steps are very, very important. That is the step S. These three steps are very, very important. Whenever a new pattern is given, whenever two irrational numbers are given, reduce into standard form. How to reduce into standard form? Only by squaring on both sides. After that, apply the concept of method of contradiction. Okay. And next model question, prove that root 5 is irrational. It's a basic question, and practice these questions also, root 2, root 3, root 7, root 11, similar questions. So proof is standard for all the numbers. So next model question, 1 by root 2 is irrational number. Same method, 1 by root 2 equal to a by b, assumption is same, okay, and apply the method of contradiction rule. And this is also same, 7 root 5 is irrational number. Next 6 plus root, already we discussed this model, first question in this exercise, 6 plus root 2 is irrational. And here the coefficients are integers, but here the coefficients are rational numbers. Otherwise all other steps are same. All other steps are same. And this is one of the very important. So in this, among these 23 questions are very important, which is not there in NCERT. And one more tough question, root 2 plus 3 by root 2 be rational. So how to simplify this? Cross multiply. If you cross multiply root 2 into root 2, 2 plus 3 by root 5 equal to p by q. 5 by root 5 equal to p by q. So what is 5 by root 5? 5 by root 5 equal to root 5 by 5 equal to root 5, which is equal to, or multiply and divide by, okay, if you cross multiply root 5 equal to 5 cube by p. Root 5 equal to 5 cube by 3, where q and p are integers, but q by p is rational. But what about this? This is rational, but this is irrational, which is not possible, and hence this is an irrational number. So very important, these three steps are very, very important. Okay, so focus all types of problems to get full mark in this section. And yes, another new pattern, 3 plus 2 root 5 the whole square. Again it is not in standard form, squaring this 3 plus 2 root 5 the whole square equal to 3 square is 9 plus 2 root 5 square is 20 plus 2ab, 2 into 3, 6 into, this is 12 root 5, which is equal to 29 plus 12 root 5. Hereafter you can prove this as a irrational number. Squaring on both sides, the final answer is standard form of this 29 plus 12 root 5, then apply the method of contradiction. Okay, so another very important questions. So in this video we discussed 20 different types of questions, and the majority of questions from fundamental theorem of arithmetic, and 3 important tough questions from irrational number. Practice similar sum to get good mark in board exam. All the best to you for board exam. Thank you.